All right, Pac-Manians, here we are back with page 2 of Polygons 11.1. We're going to talk about regular and not regular polygons, and we're going to classify these now in a different way. So regular polygons, when line segments have the same length or when angles have the same measure, they are congruent. Congruent is just a fancy word for meaning they're the same measurement, okay? Same measurement means congruent. What does congruent mean? Same measurement. Okay. So two polygons are congruent when they have the same size and the same shape. That makes sense, right? Same size, same shape, they're same measurements, they're congruent. Okay, so things that are congruent are the same. Things that are congruent are the same. Congruent means what? Same. Got it. All right. So two polygons are congruent. We got that one. All right. In a regular polygon, all sides are congruent and all angles are congruent. So that's a special kind of polygon right here, regular. All of the sides are congruent. They're all the same length, right? And all of the angles are congruent. They're all the same measurement, right? So I'm going to look at this. I'm going to show you, when you look at this, it's labeled for you, 4, 4, 4, 4, 4, so you know they're all the same. One thing that you will often see is that they will put little lines through here. And if they all have this one line, they're all the same size. Okay? Anything with two lines would be all the same, that would all be the same size too. And then with angles, you'll get one little curve, right? And if I have one little curve, that means all those angles are the same size. If I have one curve here and two here, that means they're not the same size. So that's how you look at a polygon and know if they don't measure it for you, but they mark it for you. That's how you're going to know. All right? And then not a regular polygon, it's not all the sides are congruent. And I'm going to write this in here, and, or all the angles are not congruent, or both of them are not congruent, okay? If it's out of whack in any way, it's not a regular polygon. So it is much easier to be a not a regular polygon than it is to be a regular polygon, okay? So you can use markings. I'd already talked about that. See how there's one line here and two there, one line here and two there. That means they're different sizes, all right? So let's label the Venn diagram and classify the polygons in each group, then draw a polygon that belongs only to each group. So if I look at this side of this, and then I'm gonna look at that side, and then we're gonna look at the middle. On this side, what do they have? Congruent what? Well, we've only been talking about two things, sides and angles. Does it have congruent angles or congruent sides? So I look at the sides, and I can tell right away they're not the same, right? It's not a perfect square. So this is gonna be congruent angles, and these ones look a little different. They're not curved. The reason they're not curved, does anybody know? Right, they're right angles. So those are always marked by a little square, which is important to know later on. And then over here, I've got congruent what? Well, it's not angles, so it must be sides. If I look at them, one line, one line, one line, yep. One line, one line, one line, one line, one line, one line, yep. So we're good on that. And in the middle, they have congruent what? Angles, right? And sides. Congruent angles and sides. So this is a regular polygon. All right, and then it says draw an example that would be in each group. It's really hard for me to think of another one of these, but I can just draw another one of these, right? Something like that. Just make sure that they're different, right? And I would just mark it as different, like this, right? And then I would draw my little boxes. All right, that's another example of one of those. If I want to draw another one of these, I have to have all the same sides. It can be really hard to do that and not have the angles be the same. For me, especially because my brain is symmetrical when I start thinking of things. One example that I saw was kind of like a little plus sign. And you can do this for octagon. Now that doesn't look so great. Don't judge my drawing, but I would just do this, right? And that would indicate that my intention was for all those to be the same. Now, if you look at my angles here, I've got a right angle here on the inside, but look what I have here. Okay, so that's actually 270 degrees. That's 90, and 270 is 360 total. Keep that in mind for later on. Okay, so, and then in the middle, I can draw a pentagon, a regular octagon. Those are so much easier to do. If I draw a pentagon, 1, 2, 3, 4, 5, I can do that, right? And then I just mark my angles as all being the same. And that's that shape. But you can, if you look back on the previous page, you can do it for an octagon, right? You can do it for lots of shapes. Okay. All right, I'm going to erase this, so pause this if you need to copy this down, and then I'm going to do the bottom part of this page real quick. Okay. All right, the bottom part's pretty darn easy. All we've got to do, take a look. What shape is that? Everybody's known this since, kindergarten, right? That's a triangle. Tri meaning 3, right? 1, 2, 3. Are all the sides and angles congruent? Well, if I look at it, one line, one line, one line, all the sides are the same length. One curve, one curve, one curve. All the angles are the same, right? So this is a yes. And so, is it a regular polygon? Yes or no? Yeah, because all the measurements are identical on all sides, right? So this is a yes. All right, that's that one.